Hey everyone, Sebastian here, back again with more SAT math. This time I'm doing a video on geometry questions that are helpful to know for the upcoming SAT. So I did a predictions video, and in that one I'm very confident I'm putting money down that those 4 questions will show up on the test. But here, maybe not with the same numbers, but the same concept. Here, I'm not saying these will show up on the test exactly, but they're helpful concepts to know that might show up in a very different way, but they still have the same root concept. So we'll be doing 3 geometry questions today, all types. So we're going to be doing this one here, which is a circle question. Points A and B lie on a circle with center Z. The radius of the circle is 6 centimeters. Triangle ABC has a perimeter of 15 centimeters. What is the length in centimeters of AB? So if you can imagine a circle, we have a center Z. On the test, hopefully you wouldn't have to draw this out, but it might be helpful to draw it out, so I'm doing it for you all. And then we're going to have this point here, this here. Let's call this A, and let's call this B. And then this is 6, and this is 6. And what are we told? That ABC has a perimeter of 15. So if you can believe it or not, this is a hard level question. But once you draw it out, what you can see is you would do AB equals 15 minus 6 minus 6. It's going to equal 3. So triangle ABCD has 15, AB equals 3. And that's all you do. What throws people off is they think they have to calculate it more specifically. They're going to draw this out, try to make a right triangle, try to solve from there. You don't need to do that. There's no trig involved because we know the perimeter and we know 2 sides. We can find the 3rd side. So what I want you to take from this is to keep things simple, draw them out. Remember that if you have a triangle where you have 2 radii, it's an isosceles triangle, and then go from there. So let's go on to the next one. A rectangle is inscribed in a circle with each vertex lying on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is 1,296 root 3 square units. The circumference of the circle is k pi. What is k? A lot of shapes inside circles going on here. So we have a circle, we have a rectangle inside. Again, helpful to draw. Even though I'm not the greatest drawer in the world, it still helps me. You don't need to make it exact, you just need to make it so it clears up for you what's happening. So the area of the rectangle is that. So we have what we're told, the diagonal of the rectangle is twice the length of the shortest side of the rectangle. So that means that this is 2x. This is x. Automatically, right, this is a right triangle. And what you should notice is if we did it out with Pythagorean theorem, we're going to get x root 3. And I can tell you that because if the hypotenuse is double the shortest length, then it's a 30, 60, 90 triangle. So let's work it out here though without that. So we'd have x squared, let's call this y squared if you didn't know that, right? Equals 2x. And if you do know it, just skip ahead a little bit and then get to the good part. So I have x squared plus y squared. Actually, you should just pause the video and try it on your own and let me know what you get. Equals 4x squared. We would subtract x squared and get y squared equals 3. X squared, and then y equals x root 3 once you square root. Okay, so now we have that, and what you can do is do x times x root 3 equals 1296. Root 3, the root 3's cancel, so you're going to get x squared equals 1296. I'm going to erase a bit. So x equals 36. Now what happens here is, think about it again. I shouldn't have erased it, honestly, because I'm going to use it again. But that's okay. Live and learn, right? You're learning now so that you don't have to mess up on the test. So this is 2x. So that is going to be 2x equals 72. Now that's the diameter. How do I know that's the diameter? Because if you draw out a rectangle like that, the center of it is going to be the center of the circle. So that means that this line is passing through the center and it's touching both ends, so it's going to be a diameter. Now, circumference equals either 2 pi r or diameter times pi. So here it's going to be 72 pi. So then k equals 72. Okay? It's nice and clear once you do it. Again, draw it out. Don't try to complicate things too much. Put the labels on things so you understand how the numbers are lining up in the real image of it. And then you'll go from there, and it's not too bad at all. So if you have questions on this, let me know. If you have variations on it, I'd be happy to try them out for you. Okay, so now we have another one here. Intersecting lines A, B, and C are shown to the left. What is the value of x? This time we have it, so this is C, this is B, that's A. I don't think that matters too much. We're trying to find x. It's all on its own, but it's part of this triangle system. So I'm going to find the angles. So this one's going to be 72. This, because it's a vertical angle, is 21. So then this angle here, right, would be 180 minus 72 plus 21. So that's going to be 180 minus 93, which equals 87. So that goes here. So then x will be 180 minus 87. X, which equals 93. And if you remember the theorem talking about extended angles, they always add up to the two remote angles added up together in a triangle. So you wouldn't even have to do 180 minus 93. You could just say it was 93. X equals 93. So let me know what you think about this one, and let me know if you think it's too hard, too easy, anything like that. I'd be happy to hear your feedback. But I think these concepts will be important for the test, so definitely make sure you understand them. And good luck. Bye.